All right, as we start chapter 4, we're now diving into real algebra. I know that's not very encouraging, but the first 3 chapters was all skill building, and now we're going to use those skills you learned in the first 3 chapters, and we're going to start doing some serious algebra in chapter 4. Specifically, we're solving equations, and if you remember from chapter 3, an equation is simply 2 expressions that are equal to each other, or 2 mathematical expressions that are equal to each other. The key when dealing with equations is you do equal operations on both sides. Now let's look at some examples, the best way to explain this first section. Let's say in example number 1, I have x plus 10 equals 142. Now in the first section, we're going to start with very simplistic equations. They are going to become more and more complicated, and they may actually add more operations that may be required to solve. Now they gave on page 132 some basic steps of solving these, and the first one is to determine the operation found. So we're going to ID the variable and how they used it. And number 2, we're going to do what's called the inverse operation. And number 3, we're going to simplify both sides. And number 4, we're going to just check our answer to make sure we did everything correctly. Alright, so the inverse operation here, we added 10 to both sides. So inverse means opposite, so that means we are going to subtract it from both sides. Remember, whatever we do on the left side, we must do on the right side. And if we were to subtract 10 from both sides, we're left with x equals 132. Very straightforward, like I said, but they will get more and more complicated. And I could check my answer, because if x equals 132, I can plug that in. And let me do that in blue. And yes, it's more work to do this, but it also proves that your answer is correct and they are equal. So I know that that is my proper solution. And then I can circle my answer. If you take a shortcut and skip the check part, then there's always potential for error, especially on something simple. In example number 2, I have x minus 17 equals a negative 35. Well, the inverse operation of a negative 17 is or subtract 17 is to add 17 to both sides. And if we do that, we're left with x equals 18. And then if we check our answer, we get, well, is it? Oh, there you go. So let's plug this in. If I had 18 minus 17 does not equal negative 35, I can see that I made a mistake and I lost my negative sign. So I'll go back and I'll put my minus sign in there, and then I can circle my solution. So there's a clear case on why you should check every answer. So if you did drop a negative sign, you can go back and correct it. All right, example number 3, if I have 3x equals 9, and this is multiplication, so I'm going to do the inverse, which is division. And so I'm going to divide both sides by 3, and x equals 3. 9 divided by 3 is 3. I'm going to check my answer. So 3 times 3 equals 9. So if it's correct, I circle my answer. Let's try one that might just be a little bit more difficult. Let's try, now since we didn't do a division problem, let's do one of those. What if I have y divided by 2 equals 7? This would be example number 4. Well, here I'm doing division, so I'm going to do the opposite. I'm going to multiply, and so I'm going to multiply both sides by 2. The 2's cancel out, and y equals 14. And then I'm going to check my answer. 14 over 2 equals 7, and so I know that is correct. All right, take your time and make sure this is a foundational concept that you must understand, because they will get more and more difficult as we go along.